I'd like to start off this afternoon by introducing Brad Koerner, who is the Vice President of Product Development and Innovation at SEMA. And Brad has more than 20 years experience in lighting and was kind enough to come last year to talk about ambient lighting. But this year, we'd like to hear more about the DC-powered buildings from Brad. Brad, thank you. Thanks for joining us.
Thank you. So I'm very happy to be back here a second year. Last year, I presented ambient communications, which very much echoed what David spoke about at the opening keynote, which was the most creative use of smart building technology you could imagine. This year, I'm at the totally opposite end. I'm talking about one of the most foundational parts of smart building technologies, which is electricity. And why we need a revolution in just basic electricity before a lot of our smart building technologies will actually be implemented. So we're at this precipice of a DC power revolution, right? We're seeing this explosive growth of net zero energy commercial and residential buildings. We're seeing solar PV on buildings reaching grid parity, so it's now cheaper for many commercial building owners to make their own power than it is to buy their power. You're seeing battery prices plummeting so that on-site storage, smoothing off the peaks and troughs of power generation and consumption makes a lot of sense. And you're seeing almost all of the infrastructure in commercial buildings converting to DC power at some point in their structure, their infrastructure. You're also starting to see things, the winds changing, like the USGBC has just made a new LEED pilot credit for green buildings that want to use DC power systems in there. And then, LEED is a pretty good provoker of innovation in a lot of these commercial projects, so I think that will drive a lot. And just to give you some sense of the magnitude of this, I saw this great quote by Forbes: by 2030, over half of new electricity connections in the world will be off-grid. Right, so that's obviously mostly in the developing nations, but for sure in the developed nations, this is going to be a big deal. So this is California last summer, where they had not only fires started by the grid, but they then turned the grid off wholesale for people to prevent further fires. And of course, we had Australia had a devastating fire season. But hey, if you're Dutch and you're thinking, well, we don't have that, yeah, you could have that too. You could get flooded out. You could have terrible rainstorms, windstorms. The grid is becoming more creaky as it ages, and it's a problem. For commercial building owners, they don't want to rely on this anymore, right? Also, most big organizations now are facing intense pressure to decarbonize all of their activities, right? So the old generation stations don't cut it anymore. They're facing intense activism to say they can't buy their power from these sources. So you have generators they can't use being supplied by a creaky old grid that they don't want to use to very modern smart buildings. So you can see the disconnect that we have here. So it starts to look like this, where you have front of meter and behind the meter. And now for sure, the grid utilities are trying to modernize, right? They're adding digital stuff all over their grid networks. They're trying to clean up their generation. They're using wireless smart meters and blockchain and all the buzzwords, right? But the problem is those guys don't really touch inside of the building, right? So that's our community here. That's the smart building community. And we have a lot of fun devices here that are all digital and are all IP connected and are smart, right? So how do we break this divide? Well, a modern property owner is going to want this. They're going to want a power solution that's data-driven, that's intelligent, that's secure, that deals efficiently with solar and other renewables and storage before they even touch the grid, right? Because if you can't trust the grid, you have to have your own smart system to do that. And the missing piece to this is really DC power. So let's look at what an AC grid looks like here. An AC grid has literally somewhere a copper bus bar sitting in your electrical closet that's running at 240 or whatever your voltage is. So you take your grid, you stuff it on here, you take your batteries, you have to go through conversion, Every single one of your devices, even the big motors now, have to go through multiple conversions. So it's all this needless hardware. Every time you do a conversion, it's hot, you're throwing away electricity. And worse, to try to make this all make more sense or be more efficient, we've slathered on this layer of smart technologies on top of this old creaky system. So now you have digitally controlled relay switches. You have circuit breakers that are digitally monitored. You have current monitoring all over. You have dimmers, and you have smart fixtures. So all you've done is just exponentially made the projects more complex, right? So all that does, for me as a lighting specifier for many years, that just means your odds of it getting value engineered off the project just keep going up and up. So smarter, more likely to get VE'd off the project. So somewhere we have to simplify these systems at their core and get rid of all of this junk, right? Not only just for project complexity, but to do the right thing for ecology. I mean, you literally have some instances where you have closets that are filled with solar inverters from the PV sitting next to the battery inverters, and they have a little bit of AC wiring connecting them. It makes no sense anymore. You keep adding in data centers, the increase of you name it, digital signage systems, data systems, measuring systems, every single thing has some power device converting AC to DC. You have sensors that are literally consuming maybe a watt or 2 watts, burning up that same or more energy to do the AC to DC conversion. And also, the AC system has never been modernized, right? It's still using stuff that Thomas Edison would be familiar with mechanical circuit breakers. Meanwhile, power electronics have progressed tremendously, right? You have high power transistors, you have fast switching, you have abilities to control power now where there are no faults because you have microsecond level switching and fault interruption and fault management, and you have fundamental current limitation. So here, you have to wait until there's a fault, and then there's a current rush before it does anything. Here, it never gets to that stage. So it's a much safer system for human factors. So we start to add this up. You're seeing up to 15% from energy savings from needless DC to AC to DC conversions. You're reducing hardware for ecology factors, and you're reducing maintenance because you're moving to a more solid state-based modern system. And small savings add up, right? All of these instances are tiny little savings that you never can convince a project to move on, right? Hey, we're going to replace your circuit breakers with solid state stuff. Well, I'm not going to risk it. I'm the project owner. But when you start to be a big site owner, even a big box store has so much solar on it, right? And if they're trying to go net zero, they have so much battery sitting inside there that 15% is a huge difference for them, right? So how do these building owners take control? IKEA is a great example. I mean, hundreds and hundreds of stores around the world are covered with massive quantities of solar. Well, if you think about what we need, right? So retailers would love to have DC power because then you're using 48 volts, you're using 100 watts, it's low voltage, you don't need a union electrician to install it, you don't need junction boxes, you don't need armored cabling, you can skip all of that. You can move your lights around, you can put digital signage in without having power supplies hiding somewhere. You simplify all of these systems. Offices, then, you can literally have power flowing directly from your PV into your light fixtures, into your devices. USB-C really makes this very nice nowadays, right? You can have entire 100-watt systems. My computer now is an LG screen. It's USB-C to an HP laptop, USB-C to my smartphone, USB-C. So if I could get 48 volts or some voltage in, my system would be pure DC power digital. So you're going to see the systems moving this way. You've got to have the hardware, right? There's no way around it. If you want to do DC power, you've got to replace the stuff in your electrical cabinets. And then on top of that, you see the AI software. And you saw the other speakers today presenting a lot of this, but it works a lot smoother when you have solid-state digital hardware actually controlling your flow of electrons. And then you start to think holistically about, and it's solar, and it's battery, and it's USB-C, and so on. And it makes a lot, then, of the higher level innovations that we're seeing presented make far more sense. So what would a DC system look like? Well, you still have a copper bus somewhere in your electrical closets, but now it's running 350 to 750 volts DC. The IEC is trying to standardize that. 380 was a very popular standard for some data center work. You have solar coming straight in DC, battery going back and forth as DC. You do have a grid connection because you'll get into microgrids, you'll get into sharing power, leveling power across. There will still be a need for a grid, but instead of it just being this constant one-way flow, it's going to become bidirectional. Off of the grid, then, you're going to pull power through solid-state switching and fault interruption at different levels. You might do 350, 750 for the big stuff like data centers, auto charging, HVAC, variable speed motors. You'll pull 48 volts probably down into your PoE lighting, USB lighting, so on and so forth. And then it's hard to simplify this, but when you make a DC power board, you have it all digital on there, right? You can easily pull off the data of how much current is flowing and when. So you just make the IP connection right at the board level, at the switch level. There's not like a switch and then a digital controller and then the power supply for the digital controller. It's all part of this system. It's going to be DIN-mounted parts. The only way this works is it's going to feel very familiar to the electrical installers in the cabinets. Right now, it's also sort of this tipping point that there's a lot of power electronics hardware out there. You get these chipsets now that were developed for all these other applications. This is just one company, Vicor. I like their graphics, just showing 48 volts, how that's become so standardized. You can see almost every other format under the sun that you could possibly want for power now can be pulled on and off of 48 volts. It's similar with 380 volts. So you will have smaller companies being able to produce components, DC components, that go into the DC ecosystem without it being an expensive research project each time. So now, this is a concept I want to share where, pulling together a lot of this, you have this sort of holistic view of these systems, for what a smart building system on DC power looks like. You'll have some sort of control system that's based on human occupancy, right? Where you're going to be dealing with circadian rhythm lighting, air conditioning, however you want it. And it's cyclic. It's constantly cyclic, right? From that, you're going to have variable power source optimization. You're going to be pulling solar, grid, battery intelligently. On this side, you're going to have variable consumption strategies. You know, you can tune a data center down 10% if it's a peak demand. So what? You slow it down a little bit. You can certainly tune down auto charging facilities when it's peak demand. You could draw off of those smart cars in a peak demand situation, right? You can tune down the variable speed motors on your air conditioning and pumps. One of the things I was shocked the past 6 months I learned about is these variable peak demand charges are so amazingly fast. So a big commercial building for literally 5 minutes of power might spend, 1,000 times the normal power rate. So it's very quick. It's all automated now. So you have to have systems that can respond instantaneously. And then driving it, you get the data. So a lot of these data gathering systems, whether it's talking about the weather, calendar, bid pricing on electricity, emergency scenarios like yesterday we had Code Orange in the Netherlands, or microgrid power sharing between buildings. Suddenly it makes a lot of sense. You've tied all of this intelligence together. The BIM story, again, the great presentation on the digital twin, is really important because you've got to model buildings holistically, right? Buildings now for the WELL standard, LEED standard, all these green building standards, you can't just do point calculations and say, aha, my building consumes 1 watt per square foot. You can't do that anymore. You have to understand 365 operation of your building. You have to be able to size the solar panels. You have to be able to size the battery panels. You have to be able to pre-commission it before you ever get to a construction site. You can't do this level of intelligence walking around a dusty project with a hard hat, paying some guy who's really expensive with a laptop. All right? That doesn't work. You've got to pre-commission this, just like designing the building. You can't go to a construction site and start designing the building and sketching out your drawings. It must be done ahead of time. So BIM, digital twin, virtual models, parametric concepts where you understand the range of your buildings will be very, very important. I think you're going to see a lot of really great innovation still to come in this section. Yes, Tommy Edison did DC power, but we're way beyond that. You're going to see a lot of, I think, IP development in solid-state switching. You're going to see a lot of AI-optimized power management within the building. And you're going to have a lot of AI-optimized demand response between buildings, between the grid, between microgrids. You can think about this, that modern buildings are going to be self-contained units with flows of DC power inside. And once in a while, they'll be putting power onto a grid or taking power off of a grid. You're going to see a lot of companies taking bits and pieces of DC power. It's already like this. I came from Philips Lighting, so Signify, they preached power over Ethernet, which is a 48-volt DC system, right? You see all of these other guys from the big utilities down to ESCOs. And why would an ESCO, an energy service company, like DC power? Because you don't have to pay expensive union electricians to pull Cat5 cables. It saves a lot of money. And of course, you get the traditional guys who might be, they're all thinking about it. In fact, I talked to a very high-level person at Snyder who says, oh, we've seen this. This is all over our roadmap, DC power. We just want it to go nice and slowly because we were so invested in AC hardware. So if you're interested as a building owner, there are ways to do it today. It is a little broken, though. Right, so if you look at the middle, you have true DC systems that are using a proper bus bar, pulling DC power around. Ferroamp is a Scandinavian company, for example. DC Systems is based just outside of Amsterdam here. In Japan, you have Mitsubishi with a very nice microgrid system. Nextech is an American company. On the consumption side, you get power over Ethernet lighting, which is my world, just one example, but all the other utilities, digital signage, I mean, the consumption is endless. And of course, you've got the elephant in the room that you have all these solar companies out there are combining solar and battery systems. The only smart way to do that is it stays DC. So it seems to me like these guys could add on consumption very easily and make holistic systems. And you get a lot of nice supporting companies. Here in the Netherlands, actually, there's the TU Delft School, has a very strong EE program. They have churning out a lot of PhDs and masters in DC power. Catholic University of Leuven in Belgium is doing that. Blix is a Scandinavian startup, I forget where, that's doing nothing but solid-state circuit breakers for a variety of applications. LTech is a company that does huge data center power supplies. You know, if you want to bolt together a complete IKEA-sized store using 380 and 48 volts, all this stuff exists. You can bolt it together, and you get components guys like Vicor and a whole bunch of other ones out there. Excuse me for a minute. So just a few examples. There have been some really nice full-size buildings that have been DC power. Ferroamp is a Scandinavian startup that's doing a nice DC backbone system. They claim that this is the world's largest DC-powered office building, the Academic House in Gothenburg. 200 kilowatts of DC-connected battery, 140 kilowatts of PV panels, 100 kilowatts of fans. I hear this a lot. Yeah, but the big motors are AC. Well, they're variable speed, which means they convert AC to DC and then DC back to AC. And then you get 1,500 light fixtures, which, you know, LEDs are so efficient, that's only 12 kilowatts of power for the whole building. All DC. Excuse me. Right here in Amsterdam, you have the bank ABN AMRO made this circular pavilion for their corporate headquarters. DC Systems, again, was a pioneer in doing this. It's a proper DC system, 500 solar panels on the roof. They were one of the first that really connected USB-C sockets, building permanently installed sockets throughout as the electrical infrastructure. DC Systems also did the pulse building at the Technical University of Delft. It's a 350-volt system. You have 150 kilowatts of solar panels on it. You know, 100. You have a lot. I mean, these are commercial-grade, proper systems. They're not toys. They're not R&D projects anymore. Right now, there's a building in Washington, D.C. It's 62,000 square feet. It's going to be a net zero energy building. This is the American Geophysical Union of Scientists. Are renovating this building. Nextech is a small American startup that's worked with the Emerge Alliance and Armstrong Ceilings for the electrified ceiling grids, which are all DC powered throughout the building. So why is a lighting guy here talking about DC power? Because there's a lot of great second-level innovations. Once you can clean up the complexity of the projects and clean up the power systems and controls, we can move on. So in the lighting world, LEDs allow us to do embedded lighting. And this is what I spoke about last year here. This is my project at Philips Luminous Patterns, where we're putting all these LED lights built into the walls and ceilings that surround us in hotels and retail. Okay, that's nice, but I have to deal with all the power supplies that go behind it. So this is a great project in Los Angeles, beautiful tunnel of video light, low resolution, right? That's what the customer experiences, that's what they're paying for. And behind the scenes, this is our world. This garbage, racks and racks of power supplies converting anywhere between 100 to 240 volts into 12 volts DC or 24 volts DC, and the endless network connections. So until we get rid of this, which adds no value, if you think about lean production, this is all waste. This is pure waste. No one wants this in their building. They don't want to waste the electrical closet space. They don't want to deal with the maintenance on all these power supplies, because, hey, guess how many electrolytic capacitors are in there just waiting to pop, right? We have to get rid of this before you get to these higher level innovations throughout the buildings. So with that, I'll leave it to self. I just started a new job. You're welcome to email me at bkoerner@semanetwork.com. And I do keep a blog where I keep all the fun stuff on it, called lucep.com. So, thank you.
Wonderful job, Brad. You had me convinced there. Let's see if you had the audience convinced as well. Would anybody like to answer questions about DC-powered buildings? Where we have our microphone in a box.
Yes, sir.
I got one here and one there. We'll go with this one first, and then we'll come back to you, Eric. Yeah.
Hi, Antoine from Sharing Cloud. I'm just acquiring a new building for my company. Where should I start with?
I would start by talking to those few companies like FarrowAmp, DC Systems, or Nextech. Start to think about the big easy wins. Lighting can easily be DC power, right? Solar, battery, lighting, can you simply keep that all DC? And that's a very simple, straightforward thing that you can bolt together hardware in the electrical closet that I think the average sort of mechanical, electrical, plumbing engineering service can figure out if they really try. The problem is there's so much inertia. These guys, they just want to take their spec sheets that they used on the last 10 projects and throw it into your project. They don't want to waste the time to even try. But if you push them a little bit, it's really not that hard to do. And, to get those higher level benefits that I talked about, you have to, that's like a lot of the comments earlier today. There's hundreds of suppliers out there competing in the smart building world. How do you layer that intelligently on top of a DC system?
I think that's actually the thing that struck me that I like very much about this presentation. It's this repeated message that the best way to get quicker to a smart building is to start from the ground up and to do the right thing the first place and get rid of the legacy. I mean, it's a repeated message in different areas. There's another question over here, Eric. Better throw that, see if you can toss it. Watch out for the ladies. There you go.
Yes, so my question is about the residential and the existing building stock out there. Do you see DC being an alternative there as well, or is it just
in
for
residential?
New building? Yeah, and for existing buildings?
Residential, I think DC power makes a lot of sense for multi-unit residential and hospitality. And the reason there is because you have a very high density of very low wattage and low power devices, right? You have your switches, your sensors, your LED lights, your digital signage, and it's also concentrated. So you take everything times 100 apartments or 100 rooms, and suddenly the labor savings in pulling low voltage wire instead of mains voltage wire makes sense. I don't think you'll ever convince those projects that energy savings of marginal 10% is worth it, but the labor savings is where you're going to find those costs. Retrofits for residential, no one will make money on that. Retrofits for commercial buildings, yes. If it's a heavy retrofit and you're basically ripping out the old lighting and you're ripping out a lot of the old electrical stuff, again, cost savings for labor should be substantial when you're pulling DC, low voltage DC in particular, than the high voltage stuff. I mean, from my experience as a specifier, any contractor in the world now knows how to quote, budget, and supply Cat5 cabling on any project. So if you can move your system to Cat5 cabling, there's a lot of project benefits that go along with that.
Okay. Other questions or comments regarding DC power building or lighting as well? Two more. One over there with Kevin. No, behind you. Oh, okay, we'll go that way first. All right.
Hey,
Sir.
Rod. I'm Eric from Cisco. So we've been actually doing some of your past employee work with Signify.
Yeah.
Where we kind of experienced this in moving to a DC power type of system here in the building side is actually all about ownership.
Sorry?
It's all about ownership.
Ownership.
Ownership between the IT integrator and the electrical installer. Is this actually starting a bit of a new way of how we should start designing buildings? Should we actually now start reinventing the new closet? It's not an electrical closet, it's not an IT server room any longer. What's your view on that?
As an end specifier that's had to have arguments over turf wars on the utility closets on projects, that should have happened like a decade ago already. So I totally agree with you that this also helps code-wise if you get a lot of the high power. If you can keep the high power separate, of course, this doesn't really apply also because you have high power in DC, so it's the same thing, but you should be able to put those closets together. And there should be no more turf wars. I mean, some of the smartest lighting companies out there put cellular modems in their lighting controls. And you know why they do this? Because the IT departments in most of these corporate companies are such pain in the butts to even get an Ethernet connection that it's easier to put a cell phone connection to control your lighting system. So if you come from like outside the industry and you say, why do you have cell phone connections on, 3G cell phone connections on rack-mounted gears? This is ridiculous. I was just on a project here in Amsterdam where the lighting guy, this amazing high-tech system, data-driven lighting, was in a rack here. The IT department from the hotel owned the rack here, and they refused to put an Ethernet cable between them. Mm-hmm. So these guys had to then fly back again, like a month later, when they finally had an Ethernet connection. This is stupid stuff, but this is what cripples smart building technologies from being adopted and rolled out.
There you go.
Right? So
you're alleging that dumb activity inhibits smart building.
Yes, absolutely.
We have one more question, and we'll let you go, Brad. Kevin has a question here. If you can toss that. There we go. Coming your way. Last question.
Okay, Kevin Hilson from ISE. So you mentioned IP and what's happening in a lot of situations in IT and in broadcast. More is being brought together over Cat5 cable. So using audio over IP, video over IP, as well as to carry the IT facilities and data. So are you saying that in that kind of infrastructure, you could also run power down those Cat5s alongside those other elements?
Yes. I mean, there's a lot of, this is the power over Ethernet story, right? I've also seen people doing power and Ethernet, where you're simply using a dumb patch panel instead of a smart Ethernet switch set. This is ridiculous, but again, that the cost savings are there that they'll do these kind of jury-rigged systems to pull that together.
Pronouncing your company.
You have LED lighting fixtures now that are off-the-shelf, commercially available at over 200 lumens per watt. So you're doing troughs for like a few watts. So this notion of like, oh, we need 90 watts for a PoE standard. No, you need like 5 watts for most of this stuff. I mean, how much wattage does even a small modern LCD screen take? It takes peanuts, right? You can easily pull this over Cat5 cable. The sensors, you're talking 20,000 sensors in a building. Those sensors are like a watt each at most. So it makes total sense to just get rid of that. I mean, in the US, you think about the wiring system. You pull 120 or 277 volts. All of that has to be armored. It all has to go through junction boxes. It all has to be armored into the final piece. So you'll get like a junction box here that the union electrician installed with a little conduit that goes to the DC power thing that the systems integrator installed to convert like power for like 1 watt for a sensor somewhere. I mean, it's like $500, $600 worth of labor to pull each one of those points. It makes no sense, right? Just if I could sum one thing.
Yep.
So in the LED world, blue LEDs came out about 1997. White LEDs came out around 2005, 2006. So that was about a decade of fits and starts with LED lighting. And then after that, it just shot like a rocket. Right now, every single thing you have is LED lighting. And I think DC Power is going through the same problem right now, that there's been fits and starts for about a decade. Like Cisco, you mentioned, Philips did their PoE system. PoE, all of these never made sense because you were just moving the AC to DC conversion somewhere else in the building. Now that you have solar and battery, you're not moving the conversion, you're eliminating it completely. So it's going to make a lot more sense, and I think it's going to be, the next decade, you're going to see this suddenly taking off.
And you saw it here first on our stage. Brad,
Thanks, Bob.
thank you very much. Very good job. Thank you.